Just give me 1 second to make sure that we're
Are we live yet?
I think so. Let me just double check. Yes, we are live. Let's see. Okay, wonderful. Let's go here. Let me just close all my tabs 1 moment. Okay. Hello everyone. Welcome. Today we're reviving like my 4-year-old YouTube channel. So I'm joined today here like with Nikita Shulga, who's like one of the core maintainers of PyTorch, and he goes by Malfet on GitHub, so you might have seen him like merge your PRs. So the sort of core problem that Nikita and I wanted to talk about today is like the following. Today, for example, with the GPU mode leaderboard, the way we sort of support things like custom CUDA extensions is we use this function in PyTorch called load in line. And load in line under the hood uses NVCC. And load in line in PyTorch by default is extremely slow. Like was taking like roughly like 90 seconds to compile like a toy program. Like this is additional overhead on top of NVCC. And this is insanely slow. It's very unpleasant. So Nikita and I worked to sort of shave that down from like 90 seconds down to like 15 seconds, and then from 15 to 5. And the goal of like today is really to see, can we sort of get to the sub 1 second, like baseline where it's just like instantaneous. And we suspect that it is indeed possible with like a piece of technology that NVIDIA produces called NVRTC. So NVRTC is like actually fairly commonly used in a lot of like CUDA wrapper, Pythonic CUDA wrapper Python libraries. So things like Numba, like CuPy, etc., all use NVRTC by default. That is not the case in PyTorch. And so really the goal of today is the following. Like we wanted to basically produce standalone helper functions that would allow us to JIT compile CUDA programs that take as input PyTorch tensors and measure the compilation time relative to load in line or NVCC. And if we can sort of get the compilation time to be, 2, 5, 10 times faster, then we would have done a good job. And maybe we'll do like another stream around like merging these improvements directly in PyTorch core. So yeah, so what you can expect for today is really like we're mostly going to be looking at Nikita's screen. I'll be mostly like commenting here and there. And we'll be doing a lot of research in the meantime to sort of see how this stuff works. So yeah, without further ado, Nikita, please take it from here.
Sure, yeah. So like maybe to add a little bit, so a few corrections, and maybe a little bit of a historical background. So why something like NVRTC exists? Because all compute started with graphic shaders, and graphic shaders is just a string. You pass it into your OpenGL or DirectX compiler, and it generates a shader, right? So NVRTC kind of follows the same idea. RTC stands for real-time compilation. So you give it a string, and you get an object that like is a GPU kernel, and you can invoke it directly. You don't need to compile it ahead of time. Also, small correction, NVRTC is used in PyTorch. And to follow my favorite Picasso quote that later was stolen by Steve Jobs. So what was it said? Like, the good artist copies, a great artist steal. I'm not claiming I'm a great artist, but I'm just going to steal the code from PyTorch. I think we already have it somewhere in the depths of Torch compile, and we're just going to reuse it. Another maybe point is that, my plan is not to write a single line of C++ during the next 90 minutes. I'm going to try to write everything using something called CPython. So maybe we should start with what CPython is. So CPython is a mechanism that allows one to just like invoke Python functions written, invoke C functions written from other libraries directly in Python. And we already use CPython for many places in Torch. And again, like one of the NVRTC integrations that I think already exists uses CPython, and I know for sure that device enumeration in Torch uses CPython. So let me try. And also, I'm on a pretty old machine here with Tesla M60, which you can buy for $60. So we're not going to use any fancy technology here. It used to cost 10,000, maybe in 2015 or something. But yeah. So let's see if I have a PyTorch code somewhere.
Nikita, maybe we can make the font just a bit larger.
Is it better?
One more. Yeah, then that's good. Yeah.
Okay, cool. So yes, I'm on. I wonder if my screen is just too big. Yeah, okay, let me. Okay, now it's, yeah. So I have a Docker container. I don't have to jump into this one, but and now I'm in a Docker container because the only prep that I've done, I checked out PyTorch and built it locally so that, like, if I need to modify something, I can do it without saying, so let's wait for another 30 minutes. So I should have a PyTorch here somewhere. Yes. And if I do this, import torch, import torch file, like, let's keep up torch run 3 device equals CUDA. Just to make sure that we can do something. Cool. So we can allocate on GPU. So now let's just open NVRTC example. Oh, sorry, NVRTC documentation. Maybe we can just start by a quick example. Should we ask ChatGPT?
But to your point, by the way, like I did try using ChatGPT before for this. It writes in a fairly low-level way. So, like, borrowing your lesson around great artists steal, do you want to just steal the code from PyCUDA? I feel like
sure, we can do that, but let's see, like, write vector sum using NVRTC. Let's see if it can do something. But then later, I just don't have PyCUDA checked out, but we can try PyCUDA. Let's see. So yes, this is a very example pattern. You don't actually need it, but essentially this is your code. It creates context, it compiles a program, and create a program. And okay, that would work, right? So let's just copy the code, compile, and figure out, like, how long it will take to run.
Nikita, maybe this is a good segue into how come you can use Clang here.
Why can't I? It's a Linux. Well, do I have Clang? That's the question. I don't. Oh, so because this is a C++ code, right? So, like, the big problem that we have is with CUDA is that CUDA compiler produces beautiful optimizations, but it's very slow. So kind of the key idea is that, we're not using CUDA at all, right? So my file is CPP, and I'll be using, well, I don't have Clang. I do have G++, I hope. And obviously it couldn't find CUDA.h, so use local. Do I have user local CUDA? But funny thing is, when we're going to use NVRTC, we wouldn't need any. Okay, I have it like there, right? So user bin G++, hello NVRTC -i, and that will compile, but that will not link because I need to do the shell CUDA and the shell NVR. That will get rid of all but NVRTC errors, right? And then the shell NVRTC. And so my time to run, I don't know if it runs. That's an interesting question. Let's measure the time. It's 0.3 seconds, which is pretty neat, right? So it did well, it's a lie. It cached the results. So I need to remember where NVRTC.
Yeah, how can we force refresh the cache? Yeah, maybe let me see.
You can Google.
I'm Googling in the background, don't worry.
Yes, I will try to install strace, which is a great tool that shows what your program is doing, like what system calls it making, and I'm just going to say, like, show me all the files that you open, right? So I'm going to do strace -e open a.out. right? And that tells me, oh, it didn't open anything. Maybe I don't know. Maybe it's open add, but let's just dump it all the code. And we can grab for open. And okay. And its cache is here, NV cache. Here we go. So I'm just going to nuke this guy. And now if we measure the time again.
Yeah. So for context, there is an environment variable, it seems, called CUDA cache underscore disable in all caps. And if you set it to 1, this seems to do the job for us.
Should we test it? So I know that cache is being placed here, and we compute cache. So I find it through strace, but and we do time. And what do you want to say it again? What's the name?
So it's going to be so CUDA underscore cache underscore disable in all caps equals 1.
Equals 1. So let's see that. Oh, CUDA cache disable. Let's do it without time. And indeed, it doesn't create an NV folder. So, sorry, maybe I'm in the wrong folder. Let's define. And yes, there is no such folder. So either mechanism works. But we know that like we kind of prove the point that writing a very trivial code. Why can't I? Do I need to do semicolon? Like that. And I still don't have, oh no, I do have an NV cache. Why can't I do that? But even without a cache, like we can see that like 0.3 seconds is what it takes, and like actually 0.1 seconds. So, well, compiling trivial shader should be trivial. So now what we need to do is looking into something like that, we want to rewrite it into Python.
Right? So I mean, actually, I think there's like one more interesting thing here, which is like, this is not it's a library, right? Like it's not you're not sort of saying NVRTC at the terminal. You're just like calling a library, which means like presumably this should also work on machines where you don't have the CUDA runtime installed, presumably.
So I need something called CUDA NVRTC, but if you have PyTorch installed, every PyTorch installation is bundled with it. So there's a libCUDA, right? So libCUDA is available everywhere with every driver installation. I think NVRTC is a part of the toolkit, not part of the CUDA drivers. There is even a lower level API that one can technically use, but it's a little bit harder, right?
Okay, yeah. And then I guess like the other thing is like basically you just want to be able to like CPython this so we can like basically use PyTorch tensors. Is this what you're saying for?
Correct. Well, so we can, like, there's two from now on, like there are two paths that we can pursue. One is just say, like, so I'm on Mac where I'm streaming from, and I implemented this shader compiler, right, as kind of an example. Like, I don't know. I'm always confused about the syntax, but I essentially can do something like that, right? I can just create a function and I can compile a shader, right? And I think like the eventual outcomes that I think if this is successful, like we should have like a Torch CUDA compile kernel that will produce a similar object, and you should be able to invoke it in like a similar manner, right?
Yeah, that sounds great. And I'm sort of curious actually, how come load in line today is in the CPP extensions namespace as opposed to the CUDA namespace?
Because load in line was intended as a CPP extension, right? Like when it was initially envisioned, maybe we only run it on C, maybe. Also, I think the problem with CPP extension that is written today, it assumes that you're going to write something that use PyBind to bind into Python, right? It was never intended to say, I'm just going to write an 8-an operator, right? So this last thing, when we shave the time from like 15 seconds to 5 seconds, and when we get rid of all Python bindings and just do 8-an, right? And that allowed us to compile so much faster. But as soon as we go into like a Python binding land, it's a little bit slower. So like CPP extensions was written to write CPython extensions. But most of the people, what most of the people do with CPP extensions, they just write 8-an kernels. And I guess that's kind of a mission operand. But yeah, I don't know. And again, with CPP extensions, you can write C, you can write MPS extension, you can write CUDA extension, you can write ROCm extension, anything you want. With this one, like it would not work anywhere but on CUDA because it uses a like MPS compile shader would not work anywhere other than Mac platform because it uses a very specific syntax, right? And this like Torch CUDA compile kernel will not work anywhere because it will use similar, like a very, very specific syntax, right? But CPP extension is kind of platform agnostic. So like idea is, so this is, if we're going to continue, this is how I kind of envision it will be available in like 2.8 if people think it is useful, or in Nightlis. But for now, we're just going to write something called CPython. And let me open, so again, I know another place that uses CPython, or maybe two of them. PyTorch. I think we should be able to see something here. And we probably want to do NVRTC create program. Is that the guy? Oh, we don't have any of it here. Really? We do have it from native code, but I thought we had it from Python. No, we don't. Well, that's a bit sad.
Yeah. So interestingly enough, like one of my first thoughts looking at this was sort of like, it seems strange to me that in PyTorch we don't have like a very good sense of like which kernels are like basically JIT compiled versus AOT compiled, because then like people could make a trade-off whether they want like the binary size to be bigger or the cold start to be faster. I guess you can rely on grepping, but like that seems like kind of a bad proxy, especially if like many things go through here. So
that's true. But and also like if we use it on VRTC, I think fresh off the press, I can send you this one we just discussed today, filed by one of them. I hope you didn't close the issue. Yes. So here's the funny part. If you use it on VRTC, so lots of special function use jitterator that calls to VRTC. It can change the locale of the program you're running in. It is fixed in CUDA 12.7 and above, but before that, it was an interesting side effect. So kind of, yeah, be aware of that. But anyway, so I don't think we have this example, but I know that when I do enumeration, I use something called CTypes. Yes, here we go. And that's what I'm going to use to call this function. So like if you look again into the code here, the interesting thing about this NVRTC is that it is like a C API. It's not C++. It's very important because when you do something with C++, you're like, how to say that? Your function name changes, it gets spangled, but C function name is very, very simple. We will be able to like just use it. So let's try to replicate at least the compilation part in Python, right? So let's call it hello nvrtc.py. And let's import Torch and like here, from CTypes import CDLL. The function name is very weird, but it is what it is.
But concretely, like what we're doing is still like we're taking like a raw, like we're taking like a pointer to storage. We're gonna reinterpret that as a PyTorch tensor. So is this sort of the
yeah? So we're just going to take tensor storage and pass it to this like kernel, right? So we need this. So we have CUDA h, where h will stand for handle, and we say libcuda.so.1, and then nvrtc.h equals cdll nvrtc.so.1 as well. I don't know. Let's see. Well, actually, let me just open another session, and I can switch like that. Do I docker ps docker run? I always confuse those two commands. So from ctypes import cdll, and let me do my, okay, sorry, let me change the order of tabs. I hope we can do it in the next 30 minutes. It shouldn't be that hard. So NVRTC have a very, sorry, ctypes have a very annoying syntax. So my CUDA H is indeed my CUDA library. And I can do, that's what I like about Python. I think I can do dir. No, I can't do dir. That's a lie, but whatever. And then let's do that. And I don't have nvrtc.so.1 because it's in user local CUDA lib. And what's the name of the library? libnv. Just so there is no one. Okay. Well, they probably need so.11.1. We'll talk about it later, right? So we're not like doing production build. We're just experimenting. So .so. And indeed, I have my header, right? So I do that. Then let's make my CUDA source, right? And my CUDA source is this guy. I'm just going to copy it verbatim here. That's it, I think. PDX less than n. Okay, cool. So now I want to try to compile it. And all I need to do is this, right? So again, I'm going to try to remember how I do this, and I pass it by reference. And it needs to be C-long, I guess. So C-int, C-long, and by ref. Do I need anything else? Maybe not. So like the funny thing is, like again, if I do something like that, so there is a function called NVRTC create program, right? And it says it's a function, right? Then I can call it with argument 1, 2, 3. That's probably going to crash my process. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6. 4, 5, 6, and segmentation fault. But it proves that I can call whatever I need to call. Well, actually, maybe we don't need to do anything like that. Let's again ask a friend ChatGPT here. Can you rewrite the same code, but using types to make NVRTC calls? Like, why do we need to do it? It knows the syntax. We don't need to go anywhere. And do we just have a working code by any chance? Something tells me that we don't, but I don't know. How optimistic are you?
This is not very optimistic. The emojis make me feel like the code is going to be incorrect. That's my tell.
But I mean, it have a like ChatGPT, NVRTC. Yeah, core dumped. But we can debug that, right? So that's like, but we don't need to write the bulk part of it. So it imported ctypes, it imported numpy, NVRTC CUDA, NVRTC CUDA success, kernel, so ctypes pointer, create program by reference, and essentially that's what I didn't want to write. And I have result, and result is indeed success. So at least, you know, it succeeded with the first part. And we don't need to initialize CUDA from Python because we can use Torch, right? So we can throw away like all the
initialization logic, yeah.
And now finally, did we compile program? Yes, it compiled program. So, you know, like we almost there. Now, I think when it's going to struggle and is PTX size, get PTX size, and our PTX size is 1 kilobyte. We create string buffer. That's something I'm bad with NVRTC. Okay. And we get our PTX buffer, which is nice array. But now it tries to initialize CUDA, create context, which we couldn't care less about. You don't need to do by ref here. I think that's its problem. Yes, and we're going to crash here. No. Get function. We even get a function. Okay, this is where it takes in its problems. No. It's all same. And this is okay. It couldn't launch kernel. I wonder why.
Okay, but this is promising. I mean, if the problem is in launching the kernel, that's probably just the.
I guess because it checks. Okay, CU module get function. Man, would we crash here? I wonder. So arguments ctypes void multiplied by 4. Is that's where it's address of int arg? Why can't it do by ref? So DA, DB, DC. CUDA launch kernel. So I think it's almost there. What called hello NVRTC.cpp. Okay, I don't know how to type, but let's compare, and maybe then we need to go and check an args. An args is void star of A, B, C, and so this is what it is doing wrong, because it shouldn't be. It should be C types by ref. If I understand what's going on here, Then I suspect this is what's missing. We cannot pass what? Cannot be converted to a pointer. Okay, and int-arg needs to be c-types. What is int-arg? C-types in, yeah. Or it needs address of here. By ref div count. What am I doing wrong? Maybe this is what confuses it. It's still crash if I do something like that, but that's an interesting.
Maybe should we just do this line by line instead?
Don't know how to convert parameter 10. Okay, so now doesn't know how to do that. So like the problem here is that, let me Google what CU launch kernel actually takes, because maybe.
Yeah, in the meantime, do you mind clicking on hide where it says StreamYard is sharing your screen?
Sorry?
Where it says StreamYard is sharing your screen, do you mind just clicking on hide?
Oh, sure. Yeah, sorry. Here you go. So dimensions. Void star kernel parameters. And did we just skip stream? So we have function. That's the first argument. We have grid dimension, block dimension, 3 by 3. That's fine. Shared bytes 0. Stream is none, supposedly. Kernel parameters is what we're struggling with. And okay, let's compare with a C++ code. So we say arguments is indeed reference of this, that, and reference to this. So I think this is correct. But I need to do something like that. Okay, let's do indeed as you suggested, right? So we first do this, and then we typecast ourselves here, or we can just do PDB. So I'm going to do, like, once it's working, we're going to walk through it and like connect with Python, but let's just debug and figure out what's going on here. But essentially, so you see like operator ampersand is taking a reference, so it should be interpreted as by reference A, B, and C. Right, and then I need to pass n by reference, which is number of threads. So that's what I'm doing here. But I'm struggling to understand why it couldn't cast it later. Like, but we can again. Let's get back to our trusted ChatGPT. Oh, wait a second.
Yeah, Nikita, if you like, maybe if you could post your code in like a gist or something, I can also try to run it on my end as well while you're debugging.
Sure, sounds good. Let me just give it a second. So I'll try like that. Sure, let's do gist and cut. I'm sorry, I'm on corporate machine. Types on NVRTC.py. Here you go. It might not work, but yeah, indeed, you can like play with it as well. But I think we're 90% there, and we just need to like do the last part of. So that's a public gist. You should just go to like gist.github.com/malfit and find it. I don't know, like I can. Oh, got it. Cool. So now we step in here, and I'm curious to see what my args are. CParam, CParam, CParam. Aha. And this one is, what is CParam? But let's ask, like, again, I don't want to learn C types. It crashes because argument. Okay, did it correct the code? I'm actually loving it. Like, I don't need to remember all this antiquated syntax that no one wants to use anyway. Okay, so that's what it does.
Yeah, this makes it clear, yeah.
Probably works. So let's try that.
Yeah, so yeah.
It likes her name and everything.
Yes.
Okay, so it invoked the kernel. It failed to freeze the code because I think it misses the same by reference part. I'm 99%, but we don't care about this because we're not going to do that part, right? But essentially, like, you know, we can invoke code, and again, well, okay, let's fix core dump. Just, okay, let me update the gist so that you can run it on your end. Do you want to give a stab at figuring out what's wrong, or should we? Okay.
Yeah, I'll take a look. Although on my end, I'm getting an error, which is the provided PTX was compiled with an unsupported toolchain. So I have a different problem.
Yes. So that's an interesting part. Yes, you probably have like an older on your. You need to pass like an additional. That's a setup problem, but that's what a little bit dangerous. The good thing about PyTorch, right? And when we're going to be using Torch is that when you import Torch and try to see load NVRTC, it will load the right one that was loaded for you by PyTorch. I show you how to do it later. So I think you have like one version of CUDA and another version of something else. So CU mem3, let's see. Actually, do I have GDB or LLDB here? I do. Python, setargs, ChatGPT, and I'm just curious, what are we doing wrong? So we receive a 6segv. What are we doing? I call NVRTC destroy program. Okay, so now I need to do NVRTC destroy program. Again, if we don't need to do it, it will leak memory. And you just pass a program now. So what's it doing wrong? NVRTC. Oh, shouldn't you do it like that? I guess that's a problem. And also, just to be clear, like from a pure programming model, I think we can do it here, right? Like once I get my PTX, I don't need program anymore. Like my compiler did what it's supposed to do, and yeah, I can just destroy the program at this point.
Yeah.
So
did you find the syntax for it? I think it's like libnvrtc dot nvrt destroy program. And it takes a reference to the program.
NVRTC destroy program, and it takes pointer to a program. No.
Yeah, pointer to program. Yes.
Yeah. So that's what I'm giving to it. Oh, wait a second. So get qbin. Oh, I think I need to pass by reference.
Yes.
Okay. So that would, but again, like from pure, like once we get a PTX, we don't need the program anymore. So like, let's do it. So, oh, I know why. Because that's a very weird program paradigm. It probably cleans up the pointer so that
do we also need to unload the module, or does PyTorch do this?
Like, no. So PyTorch wouldn't do any. Yay! We don't no longer crash. So let me close this one here. Right. So
what did you do? I was alt tabbed. Sorry.
So I just passed it by reference, right? So when I'm destroying the program, I'm saying that, so, do you want to, we can switch to your computer and, well, anyway, let's continue with that exercise and connect it to Torch, right? And then we can switch to your computer and figure out like what we're missing here. So I'm updating it again because I think we can also fix that one, because when you invoke NVRTC, I bet you can pass an option. So this should just work. Just work. Cool. Now, so chat NVRTC, hello NVRTC.py. We don't need this one. So I should have nvtc.py. So I have hello nvrtc. Oh no. nvrtc.py. Cool. So we have this one. Now we want to connect it to Torch, right? So let's remove numpy. We do import Torch, right? Why does it need OS of all things? It doesn't need to import OS at all, right? So, well, CUDA kernel, we compiled, and now we don't need to do any of that. We load module. So now prepare the data. We do A equals torch rand n. B equals torch rand n, device equals CUDA, and C equals torch empty like A, right? Oh, sorry, we put n here. If you have any questions, like feel free to.
So I guess like one thing that might not be clear to people is sort of like, what does it mean to really interop like a PyTorch tensor and a CUDA tensor? So like,
there's no such thing as CUDA. So okay, maybe we can just dive into basic PyTorch and see what's going on, right? So if I do import torch, right, and I allocate a tensor, right? So let's allocate one on CPU, torch brand 512, and one on CUDA. So every tensor is backed by a storage. Well, not every tensor. We can talk about slicing in a bit, right? So here is CPU, here is CUDA. Every tensor have storage, if I can type, right? And every storage have data pointer, no? Does it? It's not called that. Again, I can.
I'll find
I wrote this code once. No. PyTorch. We can again ask ChatGPT.
It's just on the tensor, by the way. It's not on storage.
Oh, okay. So just on the tensor, storage pointer. That's convenient. It's storage underscore PTR, and that's a function, right? No.
It's data pointer. So just tensor.data pointer.
Yeah. So this is our CPU data pointer, and like this is our GPU data pointer. It doesn't matter the values, that's all random. But essentially the point here, when we have this DA, DB, and DC, all we need to do is assign them to initialize them with like our A data pointer, B data pointer, and C data pointer, right? If I understand correctly. So, well, when we do that, I'll show you when it doesn't work, but it should work in this particular example. Probably right. And then we don't need to allocate anything because like PyTorch already did all this heavy lifting for us. Like all we need to do is launch kernel now, and we're doing that. And again, we don't need to do anything like that. We can just call print C. And CUDA initialization error. 924. Sorry. Oh, because I need to. So before I can do something like that, I should allocate the data on Torch, because at this point, like it needs a valid CUDA context. I already import Torch, but like let's like allocate an empty tensor. Who cares? Torch run 3 device equals CUDA. This all looks ugly, and here you go. It just works. So I think we kind of accomplished what we allocated 90 minutes for, thanks to ChatGPT, right? I think without ChatGPT, if I have to remember all the syntax and write it by hand, I will probably spend. But again, this code is very trivial. So I don't know. Do we want to stop there and actually make sure that it is correct? So let's set the debug. So this is my C. If I do C minus I plus B, I should get a tensor of zeros. And indeed I do. So it is working.
Okay, wonderful.
I guess. And do we want to measure the time? Right. That was kind of another aspect of
compilation time is.
Yes. Okay. So also we can maybe like clean it up a little bit.
Okay, so by the way, instead of the instantiating PyTorch tensor on CUDA, I think we can just call torch.cuda.init, right?
Yeah, sure.
That would be the slightly cleaner version.
Is it like that?
Yeah, that's right. Does this work?
Nope. Because I need to.
Oh, you need to pick a device. Yeah.
No, I need to do this torch CUDA context. Well, let's debug the thing. Right, so we can compile. It works. We can get PTX. It also works. So now we want to do module load data, and at this point it needs a CUDA context. Right, so this line will fail with initialization error. Torch CUDA get default context. Is that what I'm looking for? And yes, sorry. That's what I need, right? Because I need to create it on the device, right? When I do that, this torch CUDA, is that the context manager?
The get context?
I hope so. And yes, it is. And that's actually, well, we talk about this one later. So, cool. Like, let's measure the compilation time. I don't know what you want to, like, our compilation time is essentially from here to the time we load it on device, because this is where some of the compilation will happen at this point. So is it time? Or is it time? Yes, it is time. So, and load PTX module, right? So let's assume that here is our end time. Compile time equals time.time minus start time. Does that sound reasonable? Print. And I don't know how bad I am with writing. It's 0.3 seconds, so here you go. Well, we do use cache here, so let's delete this one and measure again. It probably would be like about 0.5, 0.31. So most of the time you spend it. So actually, this is not, again, a valid benchmark, because of this 0.3 seconds, I think the 100 or 200 milliseconds is initializing the device, and this is what we're doing here. So again, like, let's do a weird thing and create a GPU tensor here. We will remove it later. Torch run. Right, because again, people will unlikely to see this one, but like, if you want to be really pedantic, that's what you need to do.
No, I mean, at this speed up rate, at this speed up rate, I think it makes sense to initialize the CUDA context early for something like this.
Yeah. So like, again, to compile vector add, you need 0.1 seconds, which is, I think, was a premise that we started this stream.
We said 1 second actually.
Yeah,
so 0.1 is sometimes better.
So it's too early for the beer, but I have a good tea.
Okay. So okay.
There, we can like spend some time cleaning it up, or I can, okay, let me delete this one, and we can maybe switch to your screen and try to debug why it fails in your case. So let me just post this guy. First of all, checking that it works. It does. And I'm updating. And if you want to do copy paste, and we can switch and debug what's going on your end, or we can like clean up this code a bit, because there are lots of like you don't like, this is nice, but you don't need to do it. You can just say, like if not equals to 0, that's a typical ChatGPT thing. It just, like to write all the helper functions. Same here. It's sufficient to just throw an error, and we can rewrite this one as a function, right? So that takes a string and returns PTX, right? So like this one would be nice to rewrite into a function, and then this part would also be nice to like rewrite into a function, and then this is actual invocation, so we can make it easier to digest. But I think the gist is pretty simple, right? So like your crux here is Q launch kernel. It is very ugly function. It exists in C. You take a kernel name, dimensions, shared memory. We don't use shared memory. We don't care about the stream, but we can probably take it from PyTorch somehow, and that's your arguments. Yeah.
So here's my thinking. Like, I think making this beautiful will require like basically like playing around with the UX. Like, I also want to have an example of this in the leaderboard, because interestingly enough, this GIST does not really require any changes in PyTorch. It's just convenient.
Yeah.
But I think the example in of itself is interesting. So yeah, maybe let's get to running it, and then I think.
Sure. Let's switch to your machine. Do you want me to stop streaming, sharing screen, and then you share screen, and we can try to debug what's going on your end? Cool. Oh, I'm still sharing. No, I'm not.
You're not. No. It's even if you are, it doesn't matter. This app lets us move back and forth. All right. So this is me. So let me go to your GIST. Not that.
Can I ask for the same thing? Can you make it bigger?
Of course.
Cool. Nice. I don't know how to. Yeah. So essentially, the NVRTC that you loaded. Can you set a breakpoint at when we import NVRTC through C types on the line 7, for example? It works like that? I didn't know that. I usually do import PDB set trace. I'm an old school. Cool. So next, and can you print libenvrtc? Just p libenvrtc. Can you run? There is open quote proc self maps. Write in Python. So open. No. So open command, then bracket. No. So open brackets and quotes /proc self maps. brace, not bracket, sorry. This is a Python. I'm confusing you. So you just call an open function. Open functions that takes a string as an argument. And the name of the argument is proc self maps. So open, just a regular, is it brace?
Function.
Yes, quote, yes, parentheses, sorry. Quote slash proc slash self slash maps. Close quote, parentheses, and then dot read. And call it a function, read as a function. And can you print it? So again, like up, just print up. It's ugly to read it this way, so just print it. No. So press up arrow, yeah, and then call this whole thing, wrap this whole thing with print call. So print parentheses, and and then close parentheses at the end. And search for NVRTC here. Just scroll up. There should be NVRTC. I'm just okay. So you invoked 12.8, and what is your driver version? Mm. 12.4. So that's what's happening. You call NVRTC from CUDA 12.8. Let me try to, we can open the documentation for NVRTC compile program, and there probably would be an option to say that we want to compile for a specific architecture.
So just for context, like proc self maps, this is like, it's sort of like, is this sort of similar to strace? I've never used this before. So you're looking at all the files that were opened by the PyTorch program, by the Python program?
It doesn't need to be, it's not a Python program. So there's a Linux, so proc is a Linux like a debugging file system. Self is a symlink to your process ID. So like if you want to be pedantic, you can get pid, but like if you do ls-la proc self, it will just say you that it points to the proc. So you can do like proc 1, you probably don't have a permission, and that will, and the maps say like all the loaded shared libraries or whatever.
I see.
And memory, So like on the left, it says like, you have these addresses. It gives you inode number, block device number, permissions, right? So some of them are read-write, some of them are read-p. So like usually you have like Rx for majority of the code. So code should never be writable. If you want to see that you are, what's it called, hacked, then probably there is a self-modified sections. But I think modern Linux is, it's really, really hard to create a modifiable code section, because that's what all the malicious programs do.
Okay, so now what?
So one thing you can do, what is your, and PyTorch is also built with 12.8 on your machine, right?
I believe so, yes.
Okay,
I think I can show you my Z-shell RC just in case, because there was some funkiness I needed to do. So this is my funkiness.
Okay.
Actually, no, this is incorrect. That's not. I haven't. ln dash yes.
So when we do get program size, create program, here we go. So let's see what NVRTC create programs arguments are. I suspect one of them is a target CUDA version or target PTX version. Create program. Headers include names. Nope. Compile program, and we have an options that we can pass, right? So there is an NVRTC compile program. Again, let's ask how trusty. Did I close my ChatGPT? Do you want to open ChatGPT on your end and just say how can I pass the target PTX to NVRTC create program, and it will give you an answer. Sorry, not create program, compile program. And support compile program options. And there should be GPU architectures. That's not what we're looking for. Locatable device code. Okay, PTXIS options equal. I'm searching, or are you searching?
Do you see my screen? I am searching.
Sorry,
yes.
I switched to different tab. But that's not, it says that you want to do compute, we need PTXIS option. So like you're on the right path. So target arch encode, I need PTXIS, yeah. Okay, equals -v, and then you say you want to compile for, you want the PTXIS options that compiles for CUDA 12.4.
That's not very helpful.
No, it's not. So there is a PTXIS option like
NVRTC compile program.
That is a PTXIS option to target.
Are options well documented in general? Yeah. In the form, they're compiler options. Yeah, no, they're not very well documented.
Actually, yeah, it feels like there isn't a way to do that, unfortunately. And maybe it's right, and this is why we bundle PTXIS with Triton. So you just need to find the NVRTC with your...
Oh, with 12. I mean, another option is like here I have like PyTorch built from source. I could just instead explicitly download the binaries for 12.4.
Yeah, well, you can just download NVRTC. You can you can do a very weird thing. You can just pip install torch build for 12.4 and grab. Oh, actually, it's even simpler. You can pip install a version of NVRTC that we want. But there should be an option. I believe there was something. Yep. So
yeah,
not CUDA 11, CUDA 12. No. So change the name in the string to CU12. Cool, and then download release history, and you're looking for 12 something. So search for 12.4 something. For example, this guy, yeah. So you can just pip install this guy, and you need to play with LD library path a little bit when you want to run your program. So yeah, you don't need to repeat that one. Is it pip show? You need pip show this thing. I don't know where it's located by default. And pip show is the name of the package. So pip show, whatever, like NVIDIA CUDA NVRTC CU12. Yeah, just. And it is located, here's location, Mark Saroufim. So can you ls this folder and search for NVIDIA something or other? Oh yeah, you can. CD, the CD NVIDIA something.
Yeah, it's here.
No, this is a distant for, but I need the actual binary. Yep, slash, and inside would be NVRTC. Yep, enter there. There was CUDA NVRTC inside of that. And there's a lib folder. And can you, so, yeah. So you need to change the name of your program. You need to load the NVRTC in your program like NVRTC so 12. And also you need to define LD library path. Yeah, you can actually just type a full path. So ctype cdll and just dump the whole string in there. The entire lengthy string. Yep, NVRTC.so.12.
And then it's .12.
Yep.
.4, right?
Yeah, for example, if you want to be really pedantic. It's just .12. There is not 12.4.
They actually have both.
No. Yeah, but NVRTC loads its own built-ins. It's a little bit weird.
I see.
So maybe that will make it work on your machine. Yeah, we'll continue. Yay! And you can delete a breakpoint. We need to solve this problem because I know we solve it in PyTorch somehow when we ship the right NVRTC. Well, other kind of a weird solution. So PTX is just, what's it called? PTX is just a string, and I think what it does under the hood is it inserts. So do you want to set a breakpoint? Anyway, so let's try it again. 3.5 seconds.
I know this is still missing some stuff, by the way.
Oh, if you want to like be very, we don't care about 0.3 versus 0.1, but yeah, sure. Okay, let's delete the cache and run it again. Your cache should be like .nv something. Oh, not 0.03 seconds. You have a very powerful machine here.
I mean, yeah, like I think you were using a potato, so like.
Yes, I was using M60. Oh. Come on, M60 is the best Maxwell GPU.
All right, so you actually made it 100 times faster so far. You see, like we should give you harder targets, Nikita. Okay, so then I think this has what to do instead of initialize CUDA context instead of doing this stuff. Okay. Sorry, you were saying?
I will. We can maybe let me check. I think I need to run to my next glorious. No, I still have 30 minutes.
Okay.
So, my point is, if you, it should be around line 70 or something, where you can set a breakpoint, and I wonder if we can just hack it there. Not line 7. Yeah, can you set a breakpoint at line 65? And print PTX here. Okay. How do you change character array into string? Can you change it into string? Can you just str PTX? So this should be just as like, no, okay. Cchar array to string, ctype cchar array to string.
It ignored it completely, yeah.
Give me a sec.
Raw. Yes, okay. I think we're close.
So you see this code and you see something at the beginning that says, yeah, so now you see it says CUDA compilation tool, blah, 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 and there should be, and you need to print it. So if you do P, it will never like do a multi-line. So not P print, just print, yeah.
Oh, just print, I see.
Oh, it still doesn't? Oh, because you need dot decode. After all, do dot decode UTF-8. Yeah, cool. So now that's your program, right? That's a CUDA assembly. And here it have, you know, the magic version number. So something tells me when you you see like target is M52, but you have see a version right above it. So there's a version something, right? So you can just easily hack this version. So I think when you use the latest NVRTC library from 12.8, it put a version something like 8.6. And like if you just replace 8.6 with 8.4, it will also work. Like it is a very silly thing that NVIDIA does with NVRTC versions, but you don't like if you target a SAM52, right? That's another thing, by the way, that we probably should change in like this compilation options, right? Is that by default, if you don't give it any options, because when you load, like if you look at the structure of the program, when we compile PTX, it doesn't know anything about your GPUs. Right? So it compiles a PTX for a very, very old, ancient architecture. So like, again, the next steps that you need to do when you do compile program, right, there is an options part that we already asked ChatGPT about, and when it says, you should specify your GPU version, I think you should, right?
Yeah, here.
Yeah, like it is unrelated, but like when you start like benchmarking, right, you can go do like torch CUDA get device properties and it have major and minor, and you should pass this major and minor here to compile for the right architecture.
Okay.
But yeah, essentially, like I think what we can do even right now, right, we can write a very so I think next step, instead of like turning, you can put it somewhere as and let the people on the leaderboard play with it, and maybe they find enough use of it. But I think, again, this C types code is really ugly. It's just because I didn't want to write any C++ code, but like we should C++ this part, right? So again, if you look at how my like Torch MPS compile shader looks like, right, it gives you, like, it simulates C types in the sense that it gives you an object that have something callable by name, and it hides all this like a program invocation or whatever. And I think this is what I want from, I don't know, do you want me to show how this, like, you've seen how compile shader works, right? And the kind of UX. So I think we should try to do the similar UX here. So essentially you do torch CUDA compile program, give it a string, and then you do dot name of the kernel and pass like a tensors, and then like the UX. Do you want me to share again?
Yeah, I mean, I think the plan makes a lot of sense. Like basically, just like having a nicer UI for this, putting all the arguments in one mega function, I think will be immediately quite useful. I think what I can do is like, I can like share the snippet with people, but I can also put up a PR draft out today. That's like makes this nice. And I guess when you're done with meetings, you can like take a look at it.
Sure. Yeah. So I think that I need to. Anyway, we can probably like target something early next week. I'm a bit busy for the remainder of the week, but yeah, like essentially, I think we kind of proved the point that with the right set of tools, it's possible. Okay, let's maybe talk about the limitations, right? So NVRTC is not a full-fledged CUDA compiler. It can do a lot of things, and this is great, but it cannot do a very, very heavy templating.
That's fine.
You cannot use trust, right? One of the very common things that, like, so if you want to use trust to do reductions, it doesn't work with NVRTC. There are some other limitations, like it cannot import any host includes. Like you need to pass all the includes to it directly. But again, maybe it's workaroundable.
I think for us, it's like actually for as far as the leaderboard stuff goes, like these limitations are fine. I understand why this limitation might not be workable if you're a library vendor, but if you're just like authoring a kernel for a specific shape for a specific D type, there's very little reason for you to have to use very heavily templated code.
Yep. And something tells me that a very similar thing will be available in this like upcoming CUDA 12. Some of the things that people was talking during GTC, that the Python front ends will be available. But again, I don't know the implementation details. Nobody knows, but I suspect they use the same NVRTC engine under the hood to produce the output. So yeah.
All right. Well, this was very exciting. I think this might be like a good time to sort of call the stream. Thank you, Nikita. Folks, if you enjoyed watching Nikita code, let me know and I can invite him again. Otherwise, yeah, like I think what I'll do is like I'll clean up the sample. I'll wrap it in a torch.CUDA function, and then we can like take a look, and hopefully this becomes something people actually use.
Sounds good. Cool. Yeah, but I think like if we want to productize, we need to move part of that into C++, unfortunately, because C types is not the reasonable interface here. Anyway, cool.
Thank you,
See you later.
Bye-bye.